Today's lesson is using exponents and logs in application problems. It involves a bunch of formulas, and we've always given you the formulas on the test, but we don't tell you what the variables stand for. Okay? In all of these problems, A is first. A is the amount at the end. Okay? There's a P in all of these. P is the amount you start with. R is the rate, interest rate. N is the number of times it's compounded. Okay, and T is time. N is things like quarterly. So N is equal to 4. Annually. N is equal to 1. Semi-annually. N is equal to 2. Monthly. N is equal to 12. Okay, get the idea. Okay, same thing. End amount. Start amount. E is E, it's a constant. R is rate. T is time. Make sure your rate and time have the same units. Okay? Same thing. Amount at end. Amount at beginning. Rate. A represents the decay rate. Decay or growth rate. And X represents time in this case. Okay? When A is greater than 1, your answer ends up being something like 0.003, and you added it to it. And if A is between 0 and 1, you're going to use R as -1. That'll make sense when we use it. Okay? So let's talk about that later. All right. Last formula is half-life. A is amount at end. P is amount at beginning. X or T is time. H represents the half-life of the material. It will change. Okay? They usually tell it for 2 years. Sometimes you have to find it. All right, so the question is knowing which equation to use. This is money that's compounded at a certain quarterly, monthly, annually. This is money compounded continuously. Okay, this is growth and decay problems, and this is to figure out half-life. Okay, so here's your application problems. And the formulas are at the top, but you'll notice that's how they'll show up on your quiz, just like this, with no explanation. You have to know what to do. You have to know this is for continuous. You have to know this is for quarterly, annually, monthly. You have to know that this is a growth and decay. Same with this. And that's half-life. That you have to know. All right? So a half-type isotope chromium has a half-life of 24 years. Half-life. Bingo. You should go, oh yeah, I need that formula. First thing you do. You take 20 grams to decay to 10. So 30 is what you start with. 10 is what you end with. And start. End with 10, start with 30. 1/2 is a constant. Time is what we're looking for, or X, and the half-life is 23. Okay, first thing you do is divide by 30. So you get 10 divided by 30 is 1/3 equals 1/2 T to the 23rd. Okay. Now, I'm going to take the log of both sides. So I have the log of 1/3. Oh, and that's okay. Log of 1/2 to the T over 23. You wrap this to the front. So you have the log of 1/3 equals T over 23 log of 1/2. Now you divide by it. So you have the log of 1/3 divided by log of 1/2. Equals T over 23. You multiply both sides by 23, and you get t is equal to 23 times the log of 1/3 log of 1/2. Calculator ready. You can put it in your calculator and get an answer. Let's do that. Let's see. Log divided by log times 23. T is equal to, dang it, T is equal to 36.45 years. Nope, hours. Okay, this was hours. This is hours. Okay, determine the interest rate on a savings account with an initial deposit of $500, compounded continuously, and yields $1,000 after 8 years. Start, end, time. Okay, continuously, you know it's a PERT. A equals P e to the RT. Amount at the end, amount you started with. R we don't know. We know T is 8. Okay, first thing you do is divide by 500. So you get 2 equals e to the 8r. Take the natural log of both sides. These go away, and you get the natural log of 2 equals 8r. So r is equal to ln of 2 over 8. Ln of 2 divided by 8 is 0.0866, which is 8.66%. Okay, how long will it take an investment of $12.50 to triple in value if it's invested at an annual rate of 10.5 compounded quarterly? That's this. So you have A equals P, the 1 plus R over N times T. Okay, so the initial amount was $12.50. It's going to triple, so $12.50 times 3 is $37.50. 1 plus, what are we looking for? That's R, so that's 0.105, make it decimal, over quarterly, which is 4, and then you have 4t. First thing you do is divide by 1250. So you get 3 equals, let's do our calculation for in the parentheses, 0.105 divided by 4. This becomes 1.02625 to the 4t. I'm going to take the natural log of both sides, it doesn't matter, and wrap my exponent to the front. And then you divide, so you have ln of 3 divided by ln of 1.02625 equals 4t. And then you divide by 4. So let's see what we get for an answer. Divided by 4. And I got 10.5 years. Alrighty? Alright, what is the rate of growth of the population of Coppell, Texas if the population was 36,000 in 2000 and 42,000 in 2020? So you're looking for this. A equals P a to the X. Sorry. A equals P a to the X. We're looking for the growth rate. Okay, it started with 36,567. It ended with 42,372, We don't know A, and how many years went by. Looks like 20 to me. So you get 42,372 divided by 36,567 equals A to the 20. I'm going to take the log of both sides. You can take logs or natural logs. It doesn't matter. Okay? Somebody do it one way, somebody do it the other, and compare your answer. See if it works. 20 times the log of A. Well, that's interesting. Now what do we do? So now I'm going to divide by 20, and I end up with the log of A equals this divided by 20. So let's do the numbers. Okay. Log 42,372 divided by 36,567 divided by 20. Oh, I got 3.199 E negative 3. What's that mean? It's 0.0031998 equals the log of A. Well, if I change forms, it's 10 raised to the 0.0031948 equals A. So since it's still in my calculator, I'm just going to do shift log, shift answer, and it tells me A is equal, A is equal to 1.00739. So you subtract the 1, that's where this comes from up here. That 1.0073 represents this, because it's growing. So you take away the 1 to figure out the R. So R is equal to 0.00739, or 7.39%. It's the growth rate. Okay? So the trick to these is know what all the symbols stand for in the equations and which one to use, compounded, continuously, quarterly, okay? Growth rate, and half-life. Good luck. Practice, practice, practice. It's how you get good at them.